In today's video, we're going to look at function operations. We're going to learn how to add, subtract, multiply, and divide functions together. Then we're going to look at how to find a composite of a function inside of a function. And all of these we're going to refer back to our previous sections on finding the domains of these composite functions, are the sum, difference, product, and quotient functions. And we're also going to look at using interval notation to express those domains. So we've used some old material. So let's look at our operations we want to look at. So the sum, we're going to let f and g be two functions that have overlapping domains. For all x common in both domains, the following properties hold true. Okay, so if I wanted to figure out what f plus g's function of x is equal to, that all I would do is take f of x function and I would add g of x function. Now, if I wanted to figure out f minus g of x, I would take my f of x function and subtract my g of x function. Now, if I wanted to find f times g, well, that would be equal to my f of x function times by my g of x function. And if I wanted to find f divided by g, which I can write like this, or using the other notation, f divided by g of x, that would be my f of x function divided by my g of x function, given that the g of x function cannot equal 0 because it's now in the denominator. Remember, the denominator cannot equal 0. So that's how you figure out your function operations. Now, if I'd asked you to find the domain of these combination of functions, the domain of the arithmetic combinations, adding, subtracting, multiplying, dividing, of functions f and g consists of all real numbers that are common for the domains of f and g, that are common domains of f and g. In the case of a quotient, there's further restriction that the denominator cannot equal 0. All right, so let's find these operations of functions, and then we're also going to find the domain of our function. And we'll show how that works out, looking back to finding this common domain. So the first one asks us to find f plus g of x. So notice that my f of x function is defined by x squared minus 1, and my g of x function is defined by x squared minus 2x plus 1. So if I'm asked to find f plus g of x, that's going to be my f of x function plus my g of x function. That's a little light, a little darker. G of x function. All right, so I take my f of x function, which is x squared minus 1, and then I'm going to add my g of x function, which is x squared minus 2x plus 1. Okay, now to do this, I'm just going to distribute positive 1, get rid of my parentheses, combine like terms, x squared plus another x squared gives us 2x squared minus 2x, the negative 1 and the positive 1 cancel out. So I end up that my f plus g of x is equal to 2x squared minus 2x. Now the next part said find the domain. So in order to find the domain of f plus g, I first have to figure out what the domain they have in common. The domain in common. So that means I need to find my domain of f. So that was this original function here, which was x squared minus 1. So x squared minus 1 does not have any of my exceptions. There's no x in the denominator of fraction. There's no x under an even radical. There's no x inside a logarithm. So that means my domain here is going to be all real numbers. Then I have to find the domain of g of x. And looking at the domain of g of x, we go back to this equation up here. And again, I ask myself, is there any x in the denominator of the fraction? No. Is there any x underneath a even radical? No. Is there any x inside logarithm? No. So our domain is going to also be all real numbers. So what domain does these two have in common? Well, everything. They're in common. And because I don't have any division or anything like this, there's no additional exception. So then I would therefore say the domain of f plus g is all real numbers. Oops, that's a parentheses. Sorry, do my box without drawing the parentheses first. And those are my two solutions for this problem. All right, so let's try f times g of x tells me I take my f of x function, which is x squared minus 1, and I times that by my g of x function, which is x squared minus 2x plus 1. And then I multiply these together. All right, so I'm going to distribute x squared to each term, so it gives me, in the second parentheses, it gives me x to the fourth minus 2x cubed plus x squared. Now I'm going to distribute negative 1 to everything in the second parentheses. Negative x squared plus 2x squared minus 1. And then combine any like terms. X squared minus x squared, the x squares cancel out. And so this is f of g of x. Okay, so I found f of g of x. Okay, again, to find the domain, I first need to figure out the domain of f of x, which we did in part 1, so we know that already. And the domain of g of x, which we did in part 1. And then, are there any additional restrictions? No. In my final equation, I ask myself those three questions. Do I have an x in the denominator? No. Do I have x underneath an even radical? No. Do I have x inside a logarithm? No. So there's no additional restrictions. So the domain of f times g is what is in common in these two. In this case, that's all real numbers. All right, so last example for this problem. I need to find g of f of negative 1. Now notice I didn't ask you to find the domain of this one. And the reason I didn't ask you to find the domain is my answer is not going to have an x in it because I'm actually evaluating this function. So remember, f of g of negative 1 means I take g of negative 1 in this case, and I divide that by my f function. What color did I do f in? Oh, I did those colors wrong. All right, so g of negative 1, and the f was in the group, and then f of negative 1. Okay, so I start with my g of negative 1, which is x squared minus 2x plus 1, and divide that by my f of negative 1, which is x squared minus 1. So let's go ahead and plug in the x's. I didn't plug in the x's yet. So that's negative 1 squared minus 2 times negative 1 plus 1 over negative 1 squared minus 1. All right, so evaluating this down, negative 1 squared is 1 plus 2 plus 1 over 1 minus 1. Okay, so you might be seeing what's happening here. That gives us 4 over 0. This should be a red flag for you, seeing a division by 0. Remember, we cannot divide by 0. So since we cannot divide by 0, g of f of negative 1 is undefined. It is not in the domain of my function. It is undefined. Does not work. Okay. Let's do another one. This time I added some radicals just to make it a little bit more interesting. So if g of x is f of x is defined by the square root of x and g of x is defined by the square root of 4 minus x squared, we want to find f divided by g of x. All right, so f of x is x, the square root of x, and g of x is the square root of 4 minus x squared. So if I'm asked to find f divided by g of x, that's my f of x function divided by my g of x function and so I simplify that down possible. There's no simplifying that we can do, so that is our solution. Now in B, we're asked to find the domain of this function. So again, we have to find the domain in common. So what's the domain of f of x? Well, the domain of f of x, I asked myself, do I have any of those problems? Do I have x in the denominator? No. Do I have x underneath a even radical? Yes. And so remember, x has to be greater than or equal to whatever's underneath that even radical has to be greater than or equal to 0. And that's already solved. So our domain of f of x is going to be greater than or equal to 0. So we're going to include the 0 and we're going to go to infinity. Okay, so that's the domain of f of x. I should have done that in orange. So that's the domain of f of x. Okay, now we're going to do the domain of g of x. All right, so first thing we ask ourselves, x underneath the denominator fraction? No. X in an even radical? Yes. So we take whatever's in that even radical and it has to be greater than or equal to 0. Oh, okay. So this one is the first time that we have a quadratic that's greater than or equal to 0. I notice these are perfect squares, so we're going to factor these. Do a better job of that. So that's 2 minus x and 2 plus x. Now, to figure out when it's greater than or equal to 0, when you have a quadratic and you have an inequality, first thing you have to do is you have to figure out when it equals 0. So I'm going to change that inequality to 0 for just a moment here. And I'm going to set each of these equal to 0. And then I'm going to solve. And I get x equals 2 and x equals negative 2. Then you make a number line. So negative 2 to 2. And you do test points. So I check some number less than negative 2, say negative 3. And I just plug that into my function. And I'm going to see if I get if it works in this statement, if I get positive value or a negative value. So that becomes 4 minus 9, which is a negative value. Something in between, so I'll try 0. That gives us 4, which is a positive value. And then something greater than 2, which I'll try 3. And that gives us a negative value. That's a 9. All right. And then what I wanted in this problem is I wanted all values that are greater than, so that would be this interval here, or equal to. So the domain of g of x is going to be from negative 2 to 2. Okay. Now I look for any, in my function here, any additional restrictions. Okay, and my additional restriction is not only does what's underneath that square root has to be greater than or equal to 0, because it's dividing by, it can no longer equal 0. So that means that bottom cannot equal 0. So my overlapping restriction is when the bottom equals 0, that would be at that 2 and negative 2. So I know that x cannot equal negative 2 and x cannot equal 2, because I already worked out where it equals 0 there. Okay, so those are my additional restrictions. So I look and see, when are these two overlapping? So this is going from, the domain of f is going from 0 to infinity. And then here we're going from negative 2 to infinity. So let me draw this on a number line. So the green domain, the domain of f, starts at 0 and goes to infinity. The domain of the green starts at -2 and goes to 2. Then for the black, we cannot include the 2, so we gotta have an open circle at 2 and -2. All right, and so the only part in which this overlaps is this part right here. So my final answer, domain of f divided by g of x, starts at 0, including the 0, goes up to 2, does not include the 2. So that would be my domain. So it's a little bit more challenging when you have restrictions. Let me clear up some room here. All right, so now let's look at composite functions. The composite, or composition, I should say, the composition of function f with the function g is noted by f of g of x. So we have this open circle here. And now what that means is you replace every x in the f function with the entire g of x function. So a function inside of a function. Now, when you're asked to find the domain of f of g of x, it is the set of all x's in the domain of the inside function, which is g. So this is my inside, and this is my outside. So this is my inside function, such that g of x, that's the range, the output, that is the range of g of x, is in the domain of f, the outside function. All right, that might sound a little confusing, so I kind of broke up the steps that in order to do this. So how do we find the domain of a composite function? Okay, you find the domain of the inside function. You evaluate and simplify the composite function. You find the domain of the composite function, the entire function. Okay, which you found in the last step. And then the domain is the union of the domains found in step 1 and step 2. All right. All right, so we want to figure out f of g of x, and then we want to find the domain of that function. So f of g of x means I take f of g of x of x, f of g of x. So that means my f function, which is the square root of x plus 4, in place of every x in my outside function, f of x, I plug in my inside function, g of x. So in place of every x in my outside function, I'm going to replace g of x into my inside function. So that becomes x squared. Then I'm going to simplify down. And this is equal to my f of g of x. Okay, so that's my composite function. Now, how do I find the domain of this composite function? First, you find the domain of the inside function, which is my g of x in this case, which is x squared. So I ask myself, do I have x in the denominator? No. Do I have x underneath an even radical? No. Do I have x in a logarithm? No. So the domain of g of x is all real numbers. Okay, then you find the domain of our composition. Keep saying composition. Okay, and so I look at my composition function, and that says Do I have x in the denominator? No. Do I have x underneath an even radical? Yes. So I said what's inside the radical has to be greater than or equal to 0. So I get x squared is greater than or equal to -4. Oh. Well, x values squared would ever give you a negative. There's none. So there's no restrictions on this. So this is also all real numbers. Because that will never work out. Okay, x will always give us a positive value. Okay, then I look, the domain is the union of these two. Well, negative infinity to infinity union with negative infinity to infinity is simply all real numbers in this case. Okay, now I'm going to go the other direction. I'm asked to find g of f of x, which is g of f of x. So now f of x is my inside function, which I'm going to highlight in red. So that's f of x is now my inside function. So I'm going to go to my g of x function, which is x squared. And I'm going to replace every f of x, every x inside of my g function with my inside function, which is the square root of x plus 4. And then I'm going to simplify this down. Well, I know square root and squares cancel out, so that just becomes x plus 4. So g of f of x is equal to x plus 4. Now to find the domain of this function. Step 1, find the domain of the inside function. Okay, the domain of the inside function is the square root of x plus 4. And so I ask myself, is there x in the denominator? No. Is there x inside an even radical? Yes. And so that has to be greater than or equal to 0. So x has to be greater than or equal to -4. So greater than or equal to -4 means my smallest value is -4, and it goes up to infinity. So I'm going from -4 to infinity. Then I find the domain of my composition, and that is the function x plus 4. So I ask myself, the function x plus 4, is there x in the denominator? No. Is there x underneath the radical? No. Is there x inside a logarithm? No. So my domain is all real numbers. Okay. Okay, where are those overlapping at? Well, from -4 to infinity. So the domain of g of f of x is going to be equal to bracket -4 to infinity. And that's how you find the domain of that function.